version is Shark Tank.
Hello Martians, our company name is Apollo 493. We came here today to ask for help funding a Mars colonization program. Our problem is that we cannot survive on Mars because there is not enough breathable oxygen.
The current solution, MOXIE, uses too much energy and has to be sent to Mars long before the mission starts.
Our solution is to extract oxygen from iron oxide found in Martian soil, also known as regolith, by creating a recurring cycle. The final product will be breathable oxygen and it will yield iron as a byproduct. Our solution is called MARS, Martian Acid Rest Synthesizer. Unlike current solutions, ours will not use a lot of energy, manual labor, and will create oxygen quicker than MOXIE. No one has ever tried to get oxygen from rest on Mars. Here's a prototype of our solution.
Bill Nye says we won't colonize Mars anytime soon. For that reason, I'm out.
Thank you for your time, but our solution would still be useful for visits to Mars.
Why did your company decide to solve the problem of creating breathable oxygen on Mars?
Well, we originally focused on the problem of exercise in space and tried to design a suit that would help astronauts, but our design was already being used.
We then shifted our focus to oxygen generation. We tried using carbon dioxide to get oxygen, but when we talked to Dan Engebretson, a biomedical engineering professor at the University of South Dakota, he said that it wasn't going to work. So we decided to use iron oxide. We brought some elements along with us to help explain the process.
We're iron oxide.
I'm an iron atom. There's 2 of me.
And 3 of me, oxygen. Together we are more commonly known as rust.
Mars is red because it is covered with iron oxide, or rust. Iron oxide will be reflected from the surface of the planet using an electromagnet.
We're hydrochloric acid.
I'm a hydrogen atom. There's 1 of me in this molecule.
And also one of me, chlorine. We're a strong acid. For every 1 iron oxide molecule in this reaction, there are 6 of us.
When we combine, we make
Water!
And
iron chloride.
Did you think about any conditions you would need for this reaction, like heat?
We did. According to Mark Scania, a senior scientist at AbbVie, the reaction works best at water's freezing point, which is 32 degrees Fahrenheit, but can be done at any temperature.
How much of each substance would you need per astronaut?
According to how stuff works, the human being needs 550 liters of oxygen per day to breathe. To make the needed oxygen, 2.6 kilograms of iron oxide will be needed. There's plenty of iron on Mars. According to the Mars Society of Canada, 22% of the regolith is made of it.
We also need 3.6 kilograms of hydrochloric acid to start the process. But after that, the byproducts from the reactions can be combined to make more.
That's the first step. Elements, explain step 2, please.
Now, using a process called electrolysis, according to the U.S. Office of Energy Efficiency and Renewable Energy, we get zapped with energy and split apart. And according to Science Direct, we get split apart using UV radiation.
Hydrogen and I are then recombined to make hydrochloric acid and restart the cycle.
Iron is a waste product, but it will be useful for other projects.
And I am the final product. People breathe me.
So you mix hydrochloric acid and iron oxide to get iron chloride and water, which can then be turned into oxygen.
That's right. The leftover hydrogen and chlorine can then come back into the process as hydrochloric acid to make an endless cycle.
That's impressive, but did you consider using anything other than iron oxide?
Yes, we originally looked at using carbon dioxide, but when we talked to Dan Engebretson, we learned it would not create very much of a reaction because of how stable a molecule carbon dioxide is. Also, Mars' atmosphere is very thin, so there's not much carbon dioxide to use.
We then looked at other substances on Mars that contain oxygen. Iron oxide was our choice because it is easily split with hydrochloric acid.
Did you confirm that with an expert?
Yes, we got confirmation for this reaction with Dr. Mark Scania. We shared our solution with him, FRC Team 111, and the teachers of Lincoln Middle School.
Well, hydrochloric acid is very strong. Wouldn't it be hard to find a material to contain it?
According to chemical safety facts, polyvinyl chloride, or PVC, is acid resistant and strong, so that's what we chose to make the device out of.
We looked at using glass, but when we talked to Becky Crownover, a mechanical engineer at NASA, she said that it would break during launch, and that metals, which they usually use to contain materials, would be dissolved by the acid. Using PVC to contain the chemicals would benefit NASA and others going to Mars.
How much does PVC cost?
It costs about $1 per foot at Home Depot.
So just to recap, we will make oxygen by extracting iron oxide from Martian regolith to create an endless cycle. The final product will be breathable oxygen and it will yield iron as a byproduct. This process will help us survive Mars.
What do you think?
We're in!
Great job, guys. Nice presentation. All right, we have a little cool 3D model here.
Lots of numbers on it.
Yeah, what do the numbers mean?
The numbers are mainly for when it's sitting out in the combination room. They correspond to the steps of the process listed on there.
Okay. So walk us through it quickly.
Okay, so the label 1 is like the final where the iron oxide would be put in.
Okay.
And then it would travel through the pipe to be combined with the hydrochloric acid, which is cycling through the circle of the two, and then the water would be mixed in with hydrochloric acid and then would go out through that pipe in the side.
Okay.
And then that's an electrolysis chamber, and then up through it the hydrogen would go one way and the oxygen would go the other way. And then the pipe that continues through the donut, that's where the iron chloride would go, and then if you turn it around, like number 5, there's a box on the other side, or the that would be where the UV radiation is added in, and then the iron would come out one pipe, and then the chlorine would go up in the other pipe, and then in step 4, you recombine it back into the donut piece.
Okay, how big is this gonna be?
It would have to depend on how many astronauts would be going to Mars, and so how much oxygen would need to be put in.
Alright,
So how did you guys choose this problem? When you first got together, how did you come together and identify?
Actually, we started with a really long list of problems, and then each person, we did groups of 2, I think, and we researched all the problems and eliminated some of them that there's already a lot of work being done on. And then we got down to exercise and oxygen production. We tried exercise, but like it said in the script, we found out that our solution was already being used, so we chose oxygen.
Did you guys come across any obstacles when you were?
We did come a few obstacles. When we were doing our research on oxygen and water generation, our first solution, as we said in the script, was using CO2. But when we talked with Dan Engebretson, sorry I cannot pronounce his name, he told us that it wouldn't work, it would take too much energy to do it. So then we switched back to exercise. That's when we found out when our solution was already being used. We switched back to oxygen and water regeneration, and then we found out that we can use iron oxide on the surface of Mars.
Usually if we ever come to a decision and we have a big challenge, we try to debate about it, and so that we can listen to everybody's opinion, and then we usually do a blind vote on it so that we're not influenced by everyone else, and that's how we come to choose solutions.
That's a good idea, a blind vote versus a vote where everybody can see.
I'm gonna get back to your solution over there, because I'm intrigued. So you're making the oxygen. Are the astronauts, do you have to make up a place for them to actually live then, that the oxygen is circulating in? Have we thought that far? And it's okay if you didn't, because there's only so many weeks in the season before regionals.
So this solution would be implemented alongside other solutions.
Okay.
NASA is looking at melting the ice caps, so this might be put in place alongside that. But we wanted to use the megalith because instead of having to be close to an ice cap, you can be anywhere on Mars. And so it's just more convenient, and it would be easier when you first get to Mars to get iron oxide than the ice from the ice caps.
Okay.
When you shared your solution, I know you guys listed a couple of professionals. Did they give you any feedback that you then kind of changed your design or changed the process a little bit? Or did they say good job?
We put out a survey with the presentation on it, and then we had them answer questions, or we are having them answer questions because we sent out the survey recently. So they're currently answering questions on our survey.
Also, one expert, Mark Scanio, when we weren't quite sure how we were going to split the iron chloride, he told us that would probably be easy to split with UV radiation, so we kind of looked at that.
What is the coolest thing you guys learned this season through your project? Or your favorite thing?
So we watched a video about how we could survive on Mars, and it was a TED Talk. It was really interesting, and it was about how our generation could live on Mars because we have all the resources necessary. We just haven't gotten there yet.
Very cool. Thank you guys so much.
Yeah.
Neat idea.
Great presentation, and thank you for the demonstration of the elements. Where were you when I took chemistry? You made it really very easy to understand. So good job, guys.
Thank you guys. Have a great rest of the day.